Hello everyone, welcome you back for this further sessions on the future trends in MEMS. In the next 10 years, the MEMS research field expected to grow rapidly in developing a wider range. Now, here in this case, as the name itself is suggested, the MEMS is nothing but a micro electromechanical systems. These technology and also the application has already emerged. This 10 years is nothing but now as a present day technology is nothing but with respect to the nanotechnological concept. Once the evolution what the MEMS it has been taken from that day, they have considered it as a 10 years. Now as you know that the MEMS devices are increasing with respect to the functional and also reaches to a diversity and also satisfying with a growing range of applications, both especially industrial volume and also consumer applications. The technological applications has grown rapidly, that too especially in the field of robotics, medicines, augmented reality, actuators, displays, and may become a contender for the emerging areas. Now, the rapid and also yet sophisticated systems design will be a reality. The MEMS design methodology is also a well known and also matured. The degree of the design and as well as sophistication will also continue to increase. The modern design and like the simulation tools which tackles a complex problem with respect to the multiphysics design and also recording time are with a great accuracy has been achieved. The design capability will reduces in the MEMS time to time depending upon the market. As we know that the electrical functions integration will continue, the MEMS devices will further enjoy the benefit with respect to the circuit integration, allowing the electrical concepts and also logical computation and also decision making functional and integrated with respect to the mechanical devices. The ability to make and as well as to manufacture the MEMS product will continue to improve the MEMS processing method and equipments and also continues to mature. As you know that the MEMS, the capability will advances steadily to a point that to a true fabless MEMS development model may become into a reality. That too especially in the field of packaging technology and also the implementation with respect to the a smaller size with respect to the components. The MEMS production will migrate to a larger wafer size. The competition will intensify as the MEMS product will gradually achieve a greater function with small size and with respect to the cost also a lower. The challenging and as well as the existing products and also the competitions with respect to the market is also a major issue. Now as you know that the MEMS is playing a major role especially in the field of either it may be in the case of the mechanical or it may be in the electrical or it may be in the medical or even in the field of the defense also it has been matured. Now the intrinsic characteristics of the MEMS, as we know that the MEMS will continue in finding a major application even in future also. The reason behind this is with respect to the miniaturization, microelectronic integration and also the parallel fabrication with high precision. As you know that the MEMS product will compete in the market and the ground of the functional richness and also small size, unique performance and with a faster speed. The advancement with respect to the MEMS is also reached to a MEMS as the technology is reached to a height and it has crossed and it reached to a heights of nanotechnology. Now, if you take an example of with respect to the devices like the sensors and actuators, as you know that the MEMS is implemented or this concept has been implemented in the field of the sensors and as well as the actuators. Now it is in general term the sensors are the devices that detects and as well as monitors physical or it may be a chemical phenomenon. Now the sensing can be broadly defined into a energy transduction process that results into a perception, whereas the actuation is an energy transduction process which produces the action. That is a major difference between the sensor and as well as the actuator. Now here, if you take an example of with respect to the radiative field, or it may be magnetic field, or it may be a thermal field, or it may be electrical field, or it may be mechanical or even chemical field. These, what we can say, the instruments, or it may be these fields, it has reached to a invasion of the MEMS technology. It's not only with respect to these fields, putting together even in the field of the medical also it has been reached. If you take an example with respect to the mechanical, here in this case, the forces, the pressure, speed, or it may be a flow rate, or the viscosities, the strains, stresses, these it can be measured very easily by using the MEMS technology. Now, the sensors and the actuators. As you know that the sensors and actuators are collectively called as the transducers, which serves as a function that transforming the signal or a power of energy into another form. Now, there are 6 major domains that especially in the field of the electrical, or it may be in the mechanical, or it may be in the chemical, or it may be in the magnetic field, thermal field. These are all the fields where the MEMS has encountered a parameter within them, and even it has reached to a maximum limits. Now, the total energy within the system can coexist in several domains and can be shifted among the domains under a right circumstances. In the field of the mechanical, as I told, the forces, the pressures, viscosity, velocity, acceleration, position, and even the stress strains, all these things, it can be measured and detected very easily by using the sensors. As you know that the sensors are sensors consideration. The sensors are of two categories. The first one is nothing but a physical sensor. The second one is nothing but a chemical sensor. The another sensor which has been evolved, which is nothing but a biological sensors also. Now, the physical sensors are used to measure the physical variables, either such as the forces, pressures, temperatures, flow rates, viscosity, strains, stresses, etc. In the case of the chemical sensors are used to detect the chemicals, the two, it may be in the field of chemical, or it may be in the field of biological also, like either it may be a pH, or it may be a binding strength, or it may be a protein limits, or it may be interactions, and so forth. There are many sensing principles are available and with a given application. As we know that the sensors develops generally a most evaluated and a number of transducing parts, and also designing according to the many sensor performance it is being used. The most important sensors characteristics are concerned and summarized with respect to the following. Now, the main important parameters normally what we are considering is the sensitivity. As we know that the sensitivity, it is defined as the ratio between the magnitude of the output signal and to the input signal. If the MEMS what it has been used, especially in the either it may be in the field of mechanical, or it may be in the field of chemical, or it may be in the field of biological, these it should measure the accurate, either it may be the frequencies, temperatures, or it may be the forces, or it may be the strains. If it is not in a position to measure the exact values, then automatically there will be a failure. The next part is nothing but the linearity. If the output signal changes proportionally with respect to the input signal, the response is said to be a linear. The linear response of the sensors, the complexity of the signal, and also the processing. But here the accuracy of the sensor is also plays a major role. Precision, it's an ability of the sensor to give a same reading when repeatedly measure the same quantity under the same condition. See, this is the most essential, that especially in the field of biological concepts, or it may be in the field of mechanical, or it may be chemical. The responsivity, or it may be resolution. It is also known as the detection limit, or it may be a minimal detection signal or minimal detectable signal. This terms as the signifies the smallest signal that it has to sense, and it has to give a noise associated with the transducer element with respect to the circuit. Now, the another 3-4 is nothing but with respect to the noise. Noise can also be applied to anything to obscure the desirable signals or the desired signals. Noise can itself be another signal, which is nothing but a interference. by which it can be found out very easily how the what we can say the amplification factors, or it may be the resistors, or it may be a persistent capacitors, or it may be inductors in the circuitry can also generate the noises. These noises is with a unique signatures. Now the next part with respect to the dynamic range. As we know, the dynamic range is a ratio between the highest and as well as the lowest detectable signal. This is a major factor that it has to be decided, especially in the field of the MEMS. The next part is with respect to the bandwidth. The bandwidth characterization sensors ability to measure the fast changing signal, especially in the field of the sensors and as well as the actuators. The bandwidth, it should be a very minimum, and immediately the actuation, it should be a faster one. The sensor reliability. As we know that the sensors performs many change over time and when placed under the harsh condition. See, the sensors reliability, it is another major factor that we have to consider while designing the MEMS. That too, especially at what application, or maybe at what temperature range, or it may be at what environment or what humidity it is working it. Now if you take an example with respect to the crosstalk, or it may be interference. See, as you know that in the case of the MEMS, there are so many devices will be there. Either it may be the ICs, or it may be a circuits, or it may be capacitors, or it may be the amplifiers. These, it should not develop a something like a interference, and it should not changes the value, or it may be the any parameter. This is another major concern, that too especially with respect to the sensors. Now if you take an example with respect to the acceleration sensor with sensitivity in one particular axis may be responded, the acceleration in the other orthogonal axis, it should be idle. The development and also the cost time. As we know that as day by day the market is changing it depending upon the consumer, or it may be a customer. It always desirable that a sensor's development process be inexpensive and fast. The time to the market is a major concern. See, if within a time if the what we can say the new inventions, if it is releasing means, then automatically the successors, or it may be the previous one will be a failure. There are many commercial successful MEMS sensors have been developed for a long time, but the cost is also another parameter. Next, to reduce the cost and as well as the development time, the level currently enjoyed by means of the application a specific integrated circuits industries would be a very appealing it. As an actuator consideration, the actuators are generally transforms energy into a non-mechanical energy domain into a mechanical domain. But especially particularly the actuation task, there could be a several energy transduction mechanisms. Now here in this case, a comparison with respect to the actuation method, especially with respect to the in the case one example I will take it here. In this case, the magnetic actuation. The moment of the force is due to the interaction between the magnetic domain with the external magnetic field is a general description, but the comment with respect to the it requires a magnetic material and the magnetic sources. But here in this case, the magnetic materials what we are using it should not disturb the other elements which has been used in the MEMS devices. The following are some of the criteria that we considering it during the design of an actuator and also selection. The first one is nothing but the torque and the force output capability. As we know that the actuators are having a major application, that too especially in the field of mechanical, or it may be in the field of the chemical. These actuators must provide a sufficient forces, or it may be a torque for the task at hand. For example, if you take an example of the micro optical mirrors which are used to detect the photons, because of the photons are lightweight and low levels of the forces which are provided by the mirror and actuators is sufficient. The range of motion, it should be something like a amount of translation, or it may be angular moment, that it should be measured under a reasonable condition with a small power consumption, which is also an important concern. The dynamic response and also the speed. As you know that the actuators must be able to produce a sufficiently a fast response. If the response is poor, automatically the system will be under failure. From the point of view, the actuator control the intrinsic resonant frequencies of the actuator devices should be greater than that of the maximum oscillation frequencies. The next one is nothing but the fabrication and also availability of the material. As we know that depending upon the market and also the potential, the cost of the MEMS actuators, there are two important strategies. One is to reduce the cost of the material and the processing time. The second one is nothing but increase in production yield and gives the process in order to produce a more functional unit in each batches. The power consumption and also energy. See, the MEMS devices which are having a major applications, it should consume a very low powers. And even with respect to the cross sensitivity and also environmental stability is also a major concern. That too, especially it has to work in a longer term with respect to the temperature variations, or it may be a humidity absorption, and even in the case of the mechanical creeps. The longer terms such as the stability, such actuators is extremely important for the ensuring the commercial and the competitiveness and the success. The footprint of an actuator is the total chip area it occupies in case of the dense actuator array. The footprint of each actuator becomes primarily a point of consideration.